Today's lesson is all about completing the square. Now, what are we really doing? We're basically changing y equals ax squared plus bx plus c, which you know normally as a quadratic, into another form of a quadratic. Now we're going to give these two things names. Now, we call the first form that we first experienced, where we did factoring and things like that on, as standard form. The second form that we were working on last day, where we were actually graphing and sketching the parabolas, is called the vertex form. So, for today's lesson, you need to ask yourself, how do we know we understand? So we actually know we understand what it is by when we actually use perfect squares to find our values. Now, I'm going to introduce you to what a perfect square is, and then we'll see how it attaches to the mathematics that we've got. Okay. Suppose we have this equation here. So we're going to go and check to see if this is a perfect square. Now, if this is a perfect square, then what we have is something that looks like this. Plus p squared, or x minus p all squared. So if I look at this problem that we have here, this is an example of a perfect square. Because when you go and factor this using either difficult factoring method or simple factoring method, you'd look at this and you'd find, well, it factors into this. It just ends up being x plus 2, x plus 2. This, when you bring the x plus 2 together, you can write it in exponential form. X plus 2 squared. So imagine that was example A. Example B would be something like this. Suppose I had x squared plus 6x plus 9. Basically, you'd end up with x plus 3, and we end up with x plus 9, x plus 3, quantity squared. So these are considered perfect squares. What we'll be doing is we're going to actually create our own perfect squares. There are hints and tricks that you can use to find out if something is a perfect square, but you know what? We don't have to do that in this course. All we have to do is create them. Today's lesson is all about creating perfect squares like these in our equations that we have for standard form. And then by doing so, that will help us create our vertex form that we were trying to get. Alright, so let's go over the key steps. So 1, if I have y is equal to ax squared plus bx plus c, right? The key idea is to do the following. Take the b term. Take b divided by 2, square it, and then add the plus and minus to a collection, otherwise known as brackets, of the x squared and x terms all in one bracket. The third part is to move the negative portion out. Number out. of the collection. By doing so, this creates the perfect square. Now, we're going to go over some examples and we're going to put them side by side to see what happens. And we're going to use different colors for each number that we add and subtract to our set. Okay, here we go. So now we're going to use brackets to put a collection around certain things, right? Now, we need to know what our B term is in our first problem. Our first problem, our B term is this. So the first thing that I want you to do is I want you to take the B term. I want you to take it, and I want you to take it, and I want you to divide it by 2, and then you're going to square it. So that number that we get here is actually 4. 4 divided by 2 is 2. Square it, and you get 4. So in our next line, what I want you to do is I want you to block off all the sections that have x squareds in it and give yourself enough space here. All right, and then basically on the outside we have plus 9. So now we have x squared plus 4x, and now here is the deal. Remember how we sat here and we calculated this specific term here. We're going to use this term in order to create our perfect square. So we're going to add 4, and then we're also going to subtract 4 in this bracket. Now, you know that if there is nothing sitting in front of this bracket, the number that is in front of this bracket is essentially the number 1. So basically what we're going to do in order to move this minus 4 out of this bracket is take our 1 and multiply it by minus 4. So we're going to get the following. Well, we're going to get y is equal to 1 bracket x squared plus 4x plus 4. Now that I've done that, remember that 1 times minus 4 that we had here. That gives us minus 4 plus 9. Now, basically, once we've done that, we have a 1, and this whole section just becomes a perfect square. And that perfect square is essentially just x plus 2 all squared. Now, in order to get that, all you have to do, if you wanted to, you could factor x squared plus 4x plus 4, but essentially you're going to get x plus 2 all squared. That is the beauty of completing the square. If you do it right, you're always going to get, your bracket is going to have the square root of the first here and the square root of the last here, and then it's going to all be squared. And then all we have to do is add the outside terms to get, well, plus 5. So that's it. We're done. Try the next problem, exactly the same. I won't say a word, just watch my solution after you've tried it. For these last three problems, they are unique, so we're going to work through them. This first equation says y is equal to negative x squared plus 8x plus 3. The key concept here is we're going to have to actually start like before, but we have an issue. You'll notice that before we didn't have a number sitting on front of our x squared term. In this case, what we want to do is we want to get rid of that. So let's just common factor out a -1 from this entire bracket. Then we'll do what our steps were from before. In this case, our common factor is -1. And we have something that looks like this. So now, the work that's in our brackets, we said that we had to look at the b term of our equation. And our b term in this case is going to be -8. So we have to do the math for that. So I'm going to put that in red here. So remember, we take -8, we divide it by 2, and then square it. Punch that in your calculator, and you're going to get +16. So that is what we have to add and subtract from our bracket. And now we have this. So our next step is to remove this -16. And remember before I said, because the -16 is in our bracket, we have to take it and hit it with the number that's sitting in front of our bracket, essentially doing a waterfall and pulling something out, otherwise known as the distributive property on the number that we pull out. Now, because of that -1 that was on the outside, when we applied it to the -16, -1 times -16 gave us +16. So now we simplify. We know that this is a perfect square. And we use x minus 4. And here's the hint. Your first term is always the square root of the first term. Your last term is always the square root of the last term in our bracket. But the sign that we have in between there is always the number in between. And now let's finish up the outside. 16 plus -3 is going to be +13. Now we'll do the same for this second problem, question number 4. Follow the steps, see what you come up with. Now, you'll notice we followed exactly the same pattern that we did here. We blocked off the sections that have our x squared and -2x. Then, from here, we look at our b term. Our b term is 2. So what we did was we basically did this. 2 divided by 2, we squared it, we got 1. So that ends up being our number that we're actually substituting in. We add it and subtract it inside our bracket. And now we go about taking out this -1 that's at the end of this bracket. We want it out of there. So we pull out our -1, ends up being x squared plus 2x plus 1, and then -1 times -1 will give us +1 plus 5. So we end up with y is equal to -1, and now this thing here is a perfect square. So square root of the first number is x. Now, to find the sign, we go to the center number, the b value. Notice it's a plus, so we're actually going to make it a plus. And the square root of the last number, what's the square root of 1? Is 1. We get squared, and then 1 plus 5 is +6, and we're done. Now, our last equation that we have to do is this one. Let's follow the same pattern again. So we're going to get y is equal to, in quantity, 2x squared minus 8x. So we put that in a bracket, and we get plus 12. Now, we want this x term to have nothing on it, so we must common factor just the number 2 out of this bracket. So let's do that. Now, plus 12. So now you notice the b squared term, the b term that we have here, it's minus 4. So in order to get what we're looking for, we're going to have to take minus 4, we're going to divide it by 2 and square it. And that ends up being 4. So we're going to have to add plus 4 and minus 4 to our equation. Following the steps we had before, we get the following. Now, you'll notice, like before, we got rid of this minus 4. Now, minus 4 and times 2 gives us minus 8. That's what happened here. And now all we have to do is turn this into a perfect square, which we've already done. So all we have to do is write the following. Y equals 2. Well, the square root of x squared is x. We look at the sign of the middle. The sign of the middle is a minus, so our middle term is minus. And our last number is 4. So we're going to square root 4 and we get 2. And that's squared. And then what's left over is negative 8 plus 12, which is positive 4. Your homework for today is the following questions. We're doing page 27. Number 1A, B, C. 3A, B, C. And all I want you to do is just to put these all in vertex form. Good luck.